So number 6 is going to be the same type of problem, only it's a little bit easier here. Okay, so now would be a great time to hit the pause button, right, and try it on your own, and then hit the play to see what I do afterwards. Okay, so okay, now that you've tried it, right, I'm going to set the two equal to each other. Even before I graph it, I'm going to set the two equal to each other. Okay, and I'm going to move everything to the right side, so it's going to give me x squared minus 2x minus 3. So I have x minus 3 and x plus 1. Okay, for myself. So I have x equals 3 and negative 1. I have two values. Okay, there's two intersection points here. Okay, so, and this is, you always have to do this, right, for every single problem when you don't have the graph, right, you need to see where it's going to be. Okay, so if I, okay, know that the intersect, so let me think about this one. This has a y-intercept of 4. Okay, and it's going to be opening down because it's a negative x squared. Okay, the other one's a line, which has a y-intercept of 1. Okay, so it's going to be something like this, okay? And I'll just extend it so they actually intersect each other. Okay? If I put my rectangle in right here, I can see it's nice because there's only two intersection points, there's only one region. It's when you get to 3 or 4 intersections, you can have multiple regions. So this is going to be nice, only one region. Okay? The upper is the 4 minus x squared, and the lower is going to be the 1 minus 2x. So the upper minus the lower, right, that change in y right there that we're going to have is going to be 4 minus x squared minus 1 minus 2x, or 4 minus x squared minus 1 plus 2x. I start to combine some like terms, and I have 3 plus 2x minus x squared. And I didn't put it in standard form because I have a negative for the x squared. So that's the height of every rectangle. The width of every rectangle is dx, and we're going to integrate from negative 1 to 3. Okay, so that's why we have to find those, because those are going to give us our bounds of the integration. I know what I'm going between. My x values are varying from negative 1 to 3. Okay, so if I look at this now, integrate. I'm sorry, I took the antiderivative. Let me plug my upper bound in, 9 plus 9 minus 9. The upper bound, my lower bound is going to be minus 3 plus 1 plus 1/3. Plug that in. Those are nicely going to cancel. I'll distribute the negative in. And so I get 9 plus 3 is 12, 11 minus 1/3. So it's 10 2/3 there. This is my region. Okay. Right. More of the same for number 7 here. Okay, so hit the pause button, try it on your own, and then go and do this. Okay, so we start, set them equal. At this point, you've already tried it on your own. My intersections, nice, there's only 2 again, so that's going to make it easier. Means one's always on top, one's always on bottom. So y equals x squared is here. 2 minus x squared is a y-intercept of 2, so it's opening down like this. Okay, there are my intersections. Doesn't really matter what the y values are, you just need to know which one's on top, which one's on bottom. Okay, if I draw on my rectangle, I can see which one's on top. It's the 2 minus x squared. 2 minus x squared is my upper. Right. My lower is x squared, so that's going to give me my change in y, or otherwise known as the height, which is 2 minus 2x squared. Now I know my integral, and that's going to go from negative 1 to 1. Do your antiderivative. Plug in your upper bound, 2 minus 2/3. Lower bound, negative 2 plus 2/3. Right? That became plus because negative 1 cubed is negative 1. Right? Distribute in your negative sign. So I got 4 minus 4/3. And I'm combining these two and combining those. So that's going to give me 2 2/3. And if you want to make it, if you want to change this to 12/3 minus 4/3, you can write this answer as 8/3. It doesn't really matter how you leave your answer when it's all said and done. Okay?